Hey, thanks everybody for sticking around. Our final speaker this afternoon is Dr. Judith Nyiraniza, and she will be talking about the effects of willow chips on nutrient cycling and soil properties. Dr. Judith is a research scientist with Agriculture and Agri-Food Canada in Charlottetown. Her research focuses primarily on nutrient management and soil health. She is the co-lead researcher for Living Labs, Atlantic Canada, here in PEI, focusing on improving soil health and water quality. So, welcome, Judith.
Thank you for the introduction, and thank you everyone who is still around. I know it's late. So, the last talk is going to be about the effect of willow chip on soil properties and nutrient cycling. So we have a student who is working on this project, Yvonne, and it's co-supervised by my colleague Yifang and Tandra, and Jacinthe is a professor at Tel Aviv University, where the student is enrolled. I want to acknowledge first my team members. There are many people behind this project who are collecting all good data. So we have Danielle Marnahan, Jessica Matheson, Anna Kostic, Dorothy Gregory, and Brian Murray. He retired, but there are also additional research assistants who retired who were working on this project. So we all know about several benefits of willow shrub. So they can be grown on marginal land along river banks. They can mitigate soil erosion. They can also retain nutrient and pesticide before reaching water bodies. They can mitigate greenhouse gas emission. And they are known to have a fast and extensive root growth. And they can also regrow after cutting. So most of the time, they can have a life cycle of 30 years, and they're going to be cut every 3 years to stimulate root growth. So once harvested, so they can be used for different purposes. So they can be used for biochar, for food, or animal bedding, or for mulching. So what we want to see here is to see if there is any agronomic benefit for someone who has a large land and he wants to use them as organic amendment. So because we know that organic amendment are really very efficient in building your soil organic carbon, but when manure and compost are not available, alternative organic amendment can be useful. So our soil are frequently and intensively tilled, and that is going to accelerate the soil organic matter mineralization. So the willow chip can be really useful for this building our soil. So this is the objective, I just said it, but what we want to focus on here is nutrient cycling and soil properties. And I will just talk about this today, but my colleague Yifang and Tandra, they have additional data set because we work as a team. So they have other data set on soil microbial diversity and abundance, but also the effect of nutrient leaching. So our willow chip were incorporated after harvest at increasing rate 0, 20, 40, and 60 metric ton per hectare. The moisture content were around 52%, and the carbon content 50%, and the CN ratio was around 48. So the willow chip was applied on soil surface and was raked in and incorporated at shallow depth between 10 and 15 centimeter depth. So this is just a timeline to show you what we did. So spring 2019, we have potato growing. In fall 2019, we applied willow chip, just 1 week right after potato harvest. So in winter, 2 winters, we incorporated these ion exchange membranes So they just look like the way you see them. They are electrostatically charged. So they can be charged positively or negatively. So if they are charged positively, they're going to attract anions, so nitrate or phosphate. But you can also use the ones that are charged negatively. In that case, you can have cations, magnesium, ammonium. So we put them in 2 winters, the first winter and the second winter. And then in spring, we did have barley underseeded with red clover. And then we left the red clover in the following growing season. So what is the advantage of using anion exchange membranes? It's because they are going to integrate that temporal variation, because nitrate is going to be very dynamic, so you can have high level today and tomorrow they are washed below the root zone. And you can have this anion exchange membrane in fall, and then you're gonna go in following spring, so they can stay all those months in the ground. And we did find them to be really working to reflect the nutrient release. And they are easy to install and to extract. So we did do an incubation study. So incubation study is done in controlled environment with ideal moisture, ideal temperature. It's not the real world, but we can have useful information from an incubation study. So what we did, we just went in that feed, we took the soil from the feed, and then we came in the lab, we applied equivalent amount of willow chip at 0, 10, 30, and 50 metric ton per hectare. And then we incubated that sample for a year. And then we went at 0, 71, 161, and 395 days. And we were adjusting the soil moisture during the study. And we did quantify the CO2 released every time just to see the carbon mineralization. And then we also quantified the mass loss. What the mass loss show you, it's just another way of seeing the mineralization rate of your product. So we're just having that willow chips, seeing how much is remaining, and separate from the soil, and then weight. We also did analyze the barley yield and total carbon nitrogen accumulated. And then 12 months after willow chip application, you analyze the soil pH, aggregate stability, soil respiration, carbon nitrogen content, and also the potassium and phosphorus in the soil. In November, after willow chip application, and the following spring, May, June, July, August, so monthly sampling, we were also analyzing the nutrients such as ammonium and nitrate and phosphate. So going through results quickly. So these are the 2 figures showing the incubation study. I don't know how much you can see, but I'll try to explain to you. So the left side is showing the incubation by weighing the mass loss. So on the vertical axis, you have the willow chip remaining dry mass in percentage. And then you have time. So you can see the full circle is your 10 metric ton, and the open circle is 30 metric ton, and then the triangle is showing your 50 metric ton. So all what you can see is that when you have the low rate, you have a sharp decrease at the beginning in terms of the mass, and then it's going to stabilize. So after 1 year, you have almost the same percentage of your initial biomass remaining. So, which is between around 65%. So on the right side, it's the CO2 release, the carbon mineralization. So this is the cumulative values of CO2. So you can see when you don't have any amendment in your field here. So this is the 0 plot without manure. So you can see that in terms of the microbial respiration, there's not much going on. It's the same with time. And then as you increase your organic amendment as willow chip, you can see that the microbial respiration does increase significantly. So this equation, you can use them to derive the willow chip mineralization rate. And we did compare these values with those in the literature. And we did find that the decomposition rate was comparable to wheat or barley straw with the same carbon to nitrogen ratio. So we did analyze also the aggregate stability, the soil microbial respiration, and soil extractable potassium 12 months after the application. As you can see here, the different letters are showing different statistical differences. So we did see that at the amount higher than 40 metric ton per hectare, we did see significant increases in the aggregate stability in soil respiration and soil extractable potassium. When we analyze for organic carbon, soil moisture content, total nitrogen, and soil pH, and mineral nitrogen in terms of potassium and ammonium, we did observe that, again, at that rate higher than 40 metric ton per hectare, we saw a significant increase in soil organic carbon, soil moisture content, but no effect on soil pH, extractable phosphorus, and total nitrogen, and neither ammonium. We also did see that willow chip applied at higher rate than 40 metric tons per hectare. We did see lower nitrate in the soil. This result from ion exchange membranes, I did see them to be interesting. So this is the first winter following willow chip application. So you can see that as you increase your willow chip rate, you have lower nitrate in using the ion exchange membrane. So this nitrate cannot really be seen as leached because we are in that shallow depth, 0 to 15, but they do tell us about potential immobilization, because to know what is leached below the root zone, we'll have to wait for Yifang results. And so this is the check without any amendment. So the check is associated with higher nitrate, and as you increase your willow chip, you see a significant decrease in nitrate. The interesting part of this is that in the second winter, that immobilization was short-lived. So it was not observed in the second winter. So probably because when we seeded the barley in the following spring with nutrient there and then growing red clover, it did probably help the mineralization of our willow chip. And in the following second growing season, there is no issue of nutrient immobilization. When we analyze for phosphate, even if we did not see significant difference in the soil phosphorus, we did see a trend with higher willow chip rate to show higher phosphate in the first winter. But again, in the second winter, we did have comparable values. So we thought that probably that phosphate higher with the willow chip application might be due to enhanced mineralization from the soil, but also extra phosphorus content in willow chip. But basically, willow chip is more a significant source of potassium than it is for phosphorus. So barley yield in the following spring. So what we did see that willow chip at rate higher than 40 metric ton per hectare was depressing barley yield, and that is consistent with what we have just seen with ion exchange membrane. So if you are planning to apply willow chip in fall and then grow a cash crop in the following spring, there is a potential risk to have your depressed yield unless you increase your nitrogen fertilizer to offset the immobilization. So what we are suggesting, if someone has a good source of willow chip, would be to seed probably forage legumes. And then, because we did not see any mobilization in the second winter, then you can go back to any cash crop. So to conclude here, the willow chip effect. So the positive effect we did see, it's really a good source to build your soil organic carbon. It's also a good source for available potassium, and it also increase your aggregate stability and soil moisture retention, and it also boosts the microbial respiration. So you can have a short-term nitrogen mobilization. That can be also a good positive thing, especially if it's going to follow a high nitrogen demanding crop such as potatoes. It can really scavenge that residual soil nitrate. The neutral effect, there was no effect on soil pH, on extractable phosphorus, or on total nitrogen or ammonium. We did see a yield suppression in the following spring, so we recommend to seed a forage legumes in the following spring. So the next step is that we just applied a second round of willow chip this last fall, and we are waiting to see more results on this from my colleagues. Thank you for listening.
Any questions for Judith on that?
What was the yield of the wood chips per hectare per acre when you were cutting after the 3-year cycle?
The yield from the willow chip,
Yes.
I can't tell. I should ask Brian. I did not quantify that because my main objective was to assess impact on the soil, not to see the productivity of my willow chip as, yes, I can't tell that.
I've seen some systems where they take and grow, perennial grass or shrubbery on low productivity soil, chop it, bring it over onto the high productivity soil, and try to keep the crop intensively. They're trying to keep the organic matter in that really high with no livestock, right? With no manure, no access to manure, and yeah, a little different study, but. I'm just curious what that relationship is for the amount of wood chips that you're generating.
Yeah, that's something to investigate. Probably, I don't know, maybe Brian may have that information. Matt Ramsey is saying about 10 to 20 ton. 10? Thank you.
Of dry matter. No, dry matter.
No, that was wet. Then it's got
That's wet.
yeah, then it's got to compost for a year.
Wow.
Thank you.
Thank you very much. Okay, that concludes our day. I'd like to remind everyone again, fill out your conference evaluation so we'll know what you liked, what you didn't like for another year. And leave your name tags and that evaluation at the registration desk when you're leaving. And again, for certified crop advisors, again, to fill out the forms. Thanks again to everyone for coming, and have a safe drive home.